All right, so in Unit 9, we're going to be talking about exponential growth and decay functions. A lot about logarithmic logarithms as well. And so we're going to start by just talking about exponential growth functions, and that's what assignment number 1 is about today. So let's go ahead and get started. Before we really start talking about what exponential growth functions are, suppose that your parents decided a while ago to give you a choice at the beginning of the year where you could have $100 every week, no matter what, or they can give you a penny the first week and then double that amount each week for an entire year. What option would you pick? Would you pick option A or would you pick option B? Suppose you pick option A. Well, there are 52 weeks in a year, and so if each of those 52 weeks you were able to get $100, you would have $5,200 at the end of the year, assuming you didn't spend your allowance on anything. So that's not a bad plan. If we compare that to what's going to happen in option B, because this is not the same thing every week, we're going to have to say, well, the first week you would get 1 penny. The second week you would get a penny, but you would double it. So you started off with a penny, but you would multiply that times 2, so you would get 2 cents. That's a penny there. So after the third week, you would take your penny, which you got the first week, and you would multiply it times 2, but you would multiply it times 2 twice. So we could say times 2, and then times 2 again, or we could just go times 2 squared. Because you started with a penny, and then you multiplied it times 2, and then you multiplied it times 2 again. Well, a penny times 2 is 4 cents. And so I want you to pay attention to this column right here, because that's going to be the beginning of an exponential equation or an exponential function. And so the fourth week, now again, you started with a penny, but you're going to multiply that by 2, 1, 2, 3 times. So it's going to be times 2 to the third power. And so that's going to be 8 cents. And we can continue that. The fifth week, that's by the end of a month, by the way, you get a whole 8 cents. The fifth week, again, you started off with a penny, but you would multiply that penny times 2, not to the 5th power, but to the 4th power, because you would double it 4 times. And that's going to be 16 cents. Well, let's skip down and figure out what we would get after the 52nd week. Again, we started with a penny, and we would multiply that penny times 2, not 52 times, but 51 times. So times 2 to the 51st power. And we would want to see, what does that give us? So you can try that on your calculator, but what you would end up getting, it would be close to 2.25, and that's in scientific notation, times 10 to the 13th power. Well, this number is too big for our calculator to fit, so it just writes it in scientific notation. What it would really be is we have the 2.25, and we would move the decimal over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 spaces. So we would have 3 zeros and then a comma, another 3 zeros and a comma, another 3 zeros and a comma, another 3 zeros and a comma. That's $22,500 billion. Now that's not the total amount, that's just the amount that you would get on the 52nd week of the year, and that would be enough to pay off our national debt, at least right now. And so you might want to consider option B. What I want you to think about, though, is this equation right here. This equation right here is an exponential function, and it starts off growing slowly. If we were to graph it, it would look something like this. It starts off real slow, but then as time goes on, it grows faster and faster and faster. And you can see that because it just doubles. Every time we move over one, it just doubles, and it keeps on doubling. That's an example of exponential growth. And so that's one example of exponential growth. Now, that may not change your opinion about whether you would choose option A or option B, because $100 a week is still a good option. But if you can get $22 trillion at the end of a year, you might want to pick that as well. All right, let's pick a different scenario. rumor read, let's say that somebody at school starts a rumor about somebody else. And let's say that as the periods go by here, this is before school. Before school, there's only one person that knows about the rumor, and that's the person that's going to start the rumor. And so by the end of first period, let's say that every period, the number of people who know about the rumor triples. So this one person tells two more people. And so at the end of the first period, 3 people know about the rumor. Started with 1 and we multiplied it times 3. Well, at the end of 2 periods, each of these 3 people tell 2 new people, and that's 6 new people plus the 3 old people. That's 9 people that know about this rumor. And again, it started with 1 person, and we multiplied it by 3 once, and then we took that and we multiplied it times 3 again. So it's times 3 squared. And so by the end of the 3rd period, it would be 27 people would know about the rumor. And again, to get that, we would take 1 times 3 to the 3rd power, because we would multiply 1 times 3 3 different times. So if we continued this, by the end of the day, how many people would know about the rumor? Well, let's go to what this function is saying here. It started with 1 person, and we're multiplying it times 3. And after 3 periods, we multiplied it times 3 times. After 2 periods, we multiplied it by 3 2 times. So after 7 periods, it'd be multiplied by 3 7 times. Well, if you take 1 times 3 to the 7th, you're going to get 2,187 people, which is probably just about all the kids that are at Homestead on a given day. And so the whole school would know about it. And again, you can see how it grows slowly at the beginning. If we were to graph it, it grows slowly at the beginning. We'd have 1 person, and then 3, and then 9, and then 27, and then it would just continue to grow faster and faster as time went on. What I want you to see here is the form of what this would look like. Again, here we started with 1 person, and it triples. The form for exponential growth functions looks like this. Y equals a times b to the x. And the a is the beginning amount. The last example with the rumor, we started with 1 person knowing about the rumor, and so we had y equals 1. The b is the growth factor, and so our growth factor with the rumor was 3. We multiplied it times 3 to the x power. So if after 5 periods, the x would be to the 5th power. After 6 periods, the x would be to the 6th power. And so the 3 is the growth factor. When we were talking about the money in your account, or the money that you'd get for allowance, it started with 1 penny, and the growth factor was 2 because it was doubling to a certain power. And so both of these are in the exact same form, and that's a form for exponential equations. So let's take a look at a different situation and see if we can figure out what the equation is going to be in exponential form. Let's suppose you put $5,000 in an account in the year 2000. And the account makes 8% interest. What will the account be worth in 2025? Well, let's first write the equation. The beginning amount is $5,000. So we're going to start with $5,000. Now, the growth factor isn't going to be 2 or 3 because your money isn't doubling or tripling. It would be nice if it was, but every year it's just growing by 8%. And so we want to multiply this by something that represents an 8% growth. A lot of people would multiply it times 0.08 because 0.08 is 8%. But if we multiplied 5,000 times 0.08, that would tell us the amount of the growth, but it wouldn't tell us the total amount. What we want to do is take 100% of this amount of money plus 8% more. That's 108%. We're going to have 108% of that amount of money after a year. And 108% is 1.08, which means we're going to multiply by 1.08, and that's going to give us how much money we would have the following year. If we just multiplied it by 1, the money wouldn't grow. We would just have 100% of our money year after year. It wouldn't shrink, but it wouldn't grow either. So if it's an 8% interest, then we would have to multiply 8% more than 100%, which is 108% to the x power. And so after 1 year, the x would just be to the 1st power. But after 2 years, it'd be to the 2nd power. In the year 2025, that's 25 years later. So to figure out that exact amount, we would start with $5,000. we would multiply it times 1.1 or 1.08 to the 25th power. And so I would suggest you try calculating that on your calculator. If you do that correctly, you're going to have 34,000, that's a 3 there, $34,242 and 30, looks like it's going to round up to 38 cents. And that's how much money you would have after 25 years. And again, that's an exponential growth function. That models what's happening to your money in that account. So let's continue with this idea, but let's talk about what would happen if you had to write an exponential function that goes through these 2 points. We've done things like this before with lines. We wrote an equation of a line that goes through those 2 points, but this time we want it to be of this form. Y equals a times b to the x power. So what I'm going to do is there's several ways to do this, but I think the easiest way is to take the biggest amount and plug those values in for the x and the y first. So for example, the y is 16, so we're going to have y, which is 16, equals, I don't know the a value, I don't know the b value, but I know that the x value in that particular case would be to the 5th power. Then I'm going to do the same thing with the lower numbers. The y here is 2, that equals a times b to the x power, and in this case it's to the 2nd power. And so this is like a system of equations that we've solved before. We use substitution or elimination. But with this one, I think it's probably easiest to divide these 2 equations from each other. We've added the equations in elimination before. We've never really divided the equations. If I divide these 2 equations, the top number divided by the bottom one, 16 divided by 2 is 8. A divided by a, those would cancel each other out. B to the 5th divided by b to the 2nd. Again, when we're dividing like bases, we subtract the exponent. That's going to be b to the 3rd. So b to the 3rd is 8. So if I take the cube root of both sides, I would get that b is 2. So I know my b value here is 2. Then I want to figure out what my a value is. So I'm going to take maybe the second equation. That is 2 equals a times b, which now I know is 2 to the 2nd power. Well, 2 to the 2nd power is 4. If I divide both sides by 4, then my a value is going to be 2 over 4, which reduces to 1/2. And so my equation is simply going to be y equals my a value, which is 1/2, times my b value, which is 2, to the x power. If you want to check to make sure you've done that right, you can plug in a number. Like if we plug in 5, 2 to the 5th is 32, half of that is 16, and I know that that point is then on the graph, or on the equation. Let's try the same thing with this one. Try this one on your own, and then start the video and make sure that you have it correct. So hopefully you started in this fashion. We know that it's going to be of this form. So all I really need to do is find the a and the b values. I know the x and y values. The first point is 10.125, that's my y value. And that equals a times b to the 5th power, because that's what x is. My second point, y is 3, and that equals a times b to the 2nd power, because that's what my x is. So if I divide the two, 10.125 divided by 3 is 3.375. That equals, my a's cancel. B to the 5th over b to the 2nd is b to the 3rd. So if I take the cube root of both sides, b is going to equal 1.5. Then I could take either one of these equations. I'm going to use this equation here, and I know that 3 equals whatever a is times b, which is 1.5 squared. And so if I take 1.5 and I square it, I will get 2.25. So it's 3 equals a times 2.25. And if I divide both sides by 2.25, I'm going to get 1.3 repeating. That's the same thing as 4/3. And so my a value is 4/3. And my equation is going to look like this. It's going to be y equals my a value, which is 4/3, times 1.5 to the x power. And I could try to make sure that I did this right. If I plug in 5 and I take 1.5 to the 5th power times 4/3, I should get 10.125. That's the kind of thing we're going to be doing on our homework today. Good luck with that. We will go over questions that you have on it tomorrow in class.